So let us introduce ourselves to functional groups. And these tend to have non-carbon atoms. So we're going to look at oxygens, sulfur, halogens, fluoro, chloro, bromo, and iodo, nitrogen as our atoms. Now, we've already seen that this is an alkane. So we know that this is an alkene, and something with a triple bond is an alkyne. You're going to say, well, why did he put a hydrogen in it? Well, alkynes need to show that it's a terminal hydrogen, or you may see it written this way, which is an internal alkyne. So let me write that down as terminal, because it's at the end, and so that's why we have a hydrogen. Note the hydrogen here to show it's terminal, as opposed to this one, which is internal. In addition to that, we've got alcohols. Now, alcohols contain a hydroxyl group. Let me write that down, hydroxyl. Not a hydroxide, but a hydroxyl or hydroxy, depending on who you talk to. So here we have an alcohol. That's an alcohol group. But related to alcohols, you can see that the bond is carbon, oxygen, and hydrogen. We need to understand that there are a number of variables within alcohols. And I'm drawing the three examples here. Now, if you look closely, we know that there's a carbon attached to every oxygen, as indicated by the blue dot. But then we have to count the carbons attached to the blue dot. Here, this is 2 carbons, so this is said to be a secondary alcohol, which is often abbreviated with the 2 superscript. Clearly here, we've only got 1 carbon attached, so this is a primary alcohol. Primary alcohol is 1 superscript 0 alcohol. And then finally at the bottom here, we've got 1, 2, 3 carbons, so this is a tertiary alcohol, which is given the abbreviation 3 superscript 0 alcohol. So it depends on whether it's primary, secondary, or tertiary, and depending on the number of carbons attached to the carbon of the alcohol. I want to point out we've still got our blue dot carbon, and then the groups are attached to that. In a similar vein, we have alkyl halides. And alkyl halides have a carbon chain with a halogen attached, be it bromo, chloro, fluoro, or iodo. Okay, obviously halides, derivatives of halogens. Alkyl because we've removed a hydrogen. So if we look at this, we've got this, or we can have this, or we can have this. Put an iodine in. And if you look closely again, we've got that attached to a carbon. And then guess what? If we count the carbons attached to that, we can determine what type of alkyl halide it is. This is primary, this is secondary, and this is tertiary. So this is a tertiary alkyl halide. And we don't specify whether it's chloro, bromo, or iodo. We simply refer to it as an alkyl halide, because they generally undergo very similar reactions, so our preference isn't too important. Just another comment is that is butane. If I do that, that becomes a butyl group with a halogen attached. So that's why it's called an alkyl group. We have lost a hydrogen to replace it with the chloro. Here formula is C4H10. This formula is C4H9Cl. We've still got the right number of bonds, but they're not all hydrogens anymore. So that's an example of an alkyl halide. Now, if I carry on a little further, I'm going to introduce to you amines. And the reason I'm doing that is that amines, alkyl halides, and alcohols are all either primary, secondary, and tertiary. Now, amines are derivatives of that all too familiar ammonia. And as we know, ammonia has 3 bonds, and don't forget it's lone pairs smiling at you there. Okay? So it's got 3 hydrogens attached. So all we're going to do is replace the hydrogens with carbon chains. Literally carbon chains. They can be from carbon 1 through to carbon, say, 17. whatever you want. So if we look at this, carbon chain, NH2, carbon chain, NH, and then finally move the paper up, carbon chain, carbon chain, carbon chain. So all we've done here is replace the 3 hydrogens with either 1 carbon chain, 2 carbon chains, or 3 carbon chains. And the carbon chains can be the same or different. So I can draw something like this, in which all the carbon chains are the same, or I can do something like this, in which the carbon chains are different. Please don't assume they're always the same. They can be different. So if we take a closer look at this, we see that there's 1 carbon chain attached to the nitrogen, so this is a primary amine. So I know you've already decided, wait, then that must be a secondary amine, because there's 2 carbon chains attached to that, which makes this a tertiary amine. Okay, so this is tertiary amine, and this is a secondary amine. But in all of these cases, you have a carbon bonded to a nitrogen through a single bond, and all we've done is replace the hydrogens with carbon chains.